All right, in our last unit, okay, talking about the atoms and the periodic table, we learned what parts of atoms there are. Okay, we know that we have a nucleus, and we know that we have electrons that are on the outside of the nucleus. Well, now we're going to talk about nuclear reactions. So what part of the atom do you think nuclear reactions deal with? The nucleus. Okay, nucleus sounds like nuclear. All right, so this whole unit, when we're talking about nuclear reactions, know that we're talking about the nucleus of an atom. Okay, we're going to be changing the nuclei of different atoms based on what we're doing. Okay, so in order to introduce this topic, I kind of want to show you different ways that nuclear reactions are shown, whether that's in like movies, songs, TV shows, things like that. Okay, I need all the side conversations to stop. So, somebody tell me, what's the first thing you think of when you think of radioactivity? Spider-Man. Spider-Man? What? Atomic bombs, right? What?
Maybe the bombs I know of.
Yeah, so we have atomic bombs, things like that. Okay? We are going to get to know the details of radioactivity, how it occurs, and things like that. All right, but first, let's see some different TV shows and things like that that talk about either nuclear reactivity or radioactivity. Okay? So, first of all, there is a song called Radioactive by Imagine Dragons. Okay? That's pretty self-explanatory. All right? Superheroes. So we have Spider-Man. Okay? Spider-Man gets bit by this radioactive spider, changes the DNA of him, and now he's able to do spider-like stuff. Okay? What's another super popular superhero that got changed?
Hulk. He got
the Hulk.
by gamma radiation.
Okay? So he... Hey, hush, hush, hush. Okay? So he got shot with gamma rays, which we're going to learn later are super, super dangerous. Okay? If you're done with your warm-up, please close your Chromebook like I asked you to. Alright, monsters, alright, so Godzilla is a result of radiation, okay? This was back in the 1950s when those Godzilla movies started getting made. We have Night of the Living Dead, where zombies came about because they were struck with radiation, alright? Most of the time, back in the day, radiation is like negative, okay? You don't want to look like a zombie, you don't want to look like Godzilla, so radiation was... pretty negative, all right? And the first things we think of are like bombs and stuff, right? So, radioactive isn't always negative, but for the most part, it's portrayed that way. The very first James Bond movie, the villain was Dr. No, okay? And he ended up dying in his nuclear reactor, okay? So that's another portrayal of nuclear energy. SpongeBob. As theory has it, the inspiration for why SpongeBob and his friends look and act the way they do maybe nuclear testing on the Bikini Atoll, maybe exposure to the radiation from atomic bombs dropped in the area of Bikini Bottom where the show is set. So Bikini Island,
who comes up with that?
Bikini Island is like real life, okay? So SpongeBob could be seen as a spin-off of this Bikini Bottom.
You just ruined that.
Creating all of these weird creatures that are in SpongeBob because of radiation. Okay? Teenage Mutant Ninja Turtles. Alright? We're going to watch their origin story.
Wait,
Have you seen?
is this one from the movie?
Alright, let me make sure my volume is turned up so that you can hear this. Okay, y'all listen. At the very beginning, he talks about how the Teenage Mutant Ninja Turtles came to be. Make sure you're listening.
I don't remember a time before living in that laboratory. That fateful night started like any other. Sachs gave us our injections. Her father made sure our vital signs were strong. And you, as always, provided us with a special treat. After the brothers went to sleep, I heard loud voices. There was the smell of smoke. Alarms sounded. Your father had discovered the truth behind the man he was working for. He set fire to the lab. His last breath was taken, trying to destroy Shredder's plan. I was terrified, but then you appeared and ushered us to safety. I never had a voice then, but I thank you now, April.
That's a wrap.
We wandered the sewers until I found this place. It was then that the mutagen that was injected into our blood began to change us in miraculous ways. I saw how your father loved you, and I knew I had to show that same love to the turtles. I became their father, and they became my sons. Like all children, they were drawn to the distractions of popular culture, and I knew one day they would want to explore the world with us. They would be ridiculed. They would need to learn to protect themselves, both mentally and physically.
Alright, so then he trains them to be able to fend for themselves and things like that. Okay? Homer Simpson, so he worked at a nuclear power plant. He was the safety inspector. Okay, so that's a shout out to nuclear energy there. The peace sign, so we like to think of the peace sign as like hippies, flower power, world peace, things like that. Okay, but the peace sign was actually originally meant for anti-nuclear weapon organizations. Okay, so they used this sign to show that they did not want the use of nuclear weapons at any point at all. Okay, so that's how nuclear radiation and nuclear energy are used in different movies and songs and things like that. What I want to do now is fill out that note sheet that I handed you guys. Oh, I did not mean to do that. I need to do this. Alright, so we're going to fill this out. There is a back to it that we're going to fill out tomorrow. So make sure that you keep it in a safe place after we finish it today. Alright, so nuclear reaction. We're going to keep in the back of our heads that it deals with nuclei of atoms. Okay? The first type of reaction we're going to talk about is fission. Alright? So, topic question. What do we want to get out of our notes today? We want to answer these two questions. What is nuclear fission?
Did we write that down?
Yes. And how does it happen? Okay, so hopefully we answer these two questions in our notes today. That's the goal. What is nuclear fission and how does it happen? Okay, some background knowledge of the word fission. Okay, so the first part of it, the fizz that we see, okay, comes from Latin and it means to split. So that tells us that fission splits something. Okay, fizz means split. So whenever we talk about fission, we're going to talk about splitting something. Okay, and that something is going to be an atom, right, Tristan, who's not writing down notes?
I did write it down.
Awesome. Stay off your phone then, please.
Don't back. No, I can't read this one. Where's the first one?
If you want to move closer, you're allowed to.
God, is it the first? Blue line. Like that, this small one.
Fizz. F-I-S-S. Alright, so fizz means to split. Now let's look at the definition of fission. Okay, so this is going to be our definition of fission. Fission is releasing the energy of an atom by splitting a large unstable nucleus into smaller nuclei and particles. Okay, so we know that fizz means to split. Now we know that fission is splitting a large unstable nucleus. Okay, we're going to put it together piece by piece. Alright, let's talk about how fission happens. Alright, so there's always a start to a process. Okay, this is where we're going to start fission at. So we're going to put start right here. Okay, this is our starting point for fission. So what starts fission is we're going to bombard giant unstable nucleus with a neutron. Okay, so we have one itty bitty neutron just floating around. Okay, and it's going to hit this big uranium atom. Okay, remember it's unstable. Alright, so this neutron is going to hit this uranium atom and cause it to split into barium and krypton. Okay, so that's the splitting part right there. Uranium turns into barium and krypton. Okay, nuclear reactions deal with the nucleus. So if I change the nucleus, I change the atom. So I can't split apart uranium and still end up with uranium. I'm going to end up with two new things. Okay, so I hit the neutron because it split it apart into two smaller ones.
Well, how do you do that?
That's just how it splits. So the mass goes 141 to barium, 92 to krypton. What's up?
I understand.
Okay.
You're really just telling us how to make a bomb.
Alright, so products of fission. Yes, we get two new elements, but we also get lots of energy. Okay, this is where nuclear power plants come into play. We use this energy from fission to power things. Okay, we also end up with 3 more neutrons. Okay, so that's the symbol for neutron. That 0 means that it is neutral. Okay, so all of this right here, all of that are the products of fission. Okay, so fission gets us barium, krypton, a whole bunch of energy, and 3 neutrons. Okay, all of those are the products of that uranium atom getting split by a neutron. Okay, let's summarize in words what happens in fission. Okay, this is going to be our little summary paragraph. The uranium breaks into barium 141 and krypton 92. Okay, so uranium splits into barium and krypton plus 3 what? It makes 3 what? Neutrons. And lots of energy. Okay, so that is a summary of what happens in fission. Start with uranium, it gets hit by a neutron. Now we have barium, krypton, lots of energy, and 3 neutrons. Linda, please get off your phone.
I think you're falling from.
Okay, so fission started with a neutron, ends with 3 neutrons. We're going to answer this question. What do you think happens to those 3 loose neutrons? What are those neutrons going to go do?
They're going to go hit more.
They're going to go hit more uranium, right? Okay, and then it's going to produce 3 more neutrons. And those neutrons are going to go hit even more uranium. What is that called whenever it just keeps happening? Alyssa, say it out loud. A chain reaction. Process is a good word for it. Okay? So whenever it leads to something else and leads to something else and leads to something else, it's called a chain reaction. So let's write the answer down to that right there. Those 3 loose neutrons, they bombard more uranium atoms. starting the fission process again and again. So those 3 loose neutrons, they're going to bombard more uranium atoms, starting the fission process again and again. And what did we call that? A chain reaction. Okay, so this gives us a chain reaction. Okay, that chain reaction is what gives us lots and lots of energy in our nuclear power plants. Okay, if fission just keeps happening naturally, then that's just more energy that we can get from it. All right, so that's how nuclear power plants get all of that energy. It's from those chain reactions. Okay, a couple of facts that you need to know about fission. All right, we just did the process. We talked about how it leads to a chain reaction. Now these are just straight facts about fission. Okay, fission takes place in nuclear power plants and in atomic bombs. Nuclear power plants and in atomic bombs. Okay, there's another place that fission occurs. Okay, if you think back to some geography class or some social studies class, and you talked about the layers of the Earth, what's in the middle? The core. Okay, what does the core look like? It's like lava, kind of. Okay, it's really, really hot, magma-like. Okay, it's really, really hot because of fission. All right, fission also occurs in the Earth's core. All right, a baseball-sized amount of uranium. A baseball-sized amount of enriched uranium has the same energy production potential of, I'm going to write this up here, 1 million gallons of gasoline.
That's crazy. So if I throw in a baseball of uranium in my car, it'll just go forever.
If you have neutrons. Okay? So it would be really cool if we could use that to power our cars one day. It would be very cheap, but we'll see. Okay, so that's a good thing. Okay, good thing is that fission produces lots and lots of energy over and over and over again. What would be a bad thing of fission?
Then nuclear waste.
Radioactive waste. Okay, so fission produces this blank right here. I'm going to write up here, radioactive waste. Okay, so like in the event of Chernobyl, okay, that nuclear power plant that exploded, yes, some people died from the explosion itself, obviously, okay, but more people died because of the radiation it gave off. In that nuclear power plant where all that fission is happening, a bunch of nuclear radioactive waste is also accumulating, okay? So when that exploded, all of that radioactive waste was released, and that's why people had to evacuate. That's why you still can't live there today, because it's so radioactive. The radiation levels are so high.
Isn't there cats with like 3 eyes or something there?
Is there what?
Cats with like 3 eyes or something?
I have no idea.
I'm gonna look it up.
Okay, we are going to watch another video about chain reactions.
Nuclear magical cat.
What's up?
What about the blank on the bottom?
Radioactive waste? That blank?
Yeah.
Okay. All right, listen. Guys, quit talking, please. Hush. Whenever we watch this video, I need you to pay close attention to what kind of words she is saying. Okay, what kind of, how she's describing these chain reactions, because we're going to use those words in a second. So make sure that you're paying attention to what types of chain reactions are going on. Colton, can you turn the light off?
And so we're going to demonstrate two different things here today. We're going to demonstrate a chain reaction, but basically two ways. Now, usually when you think of a chain reaction, you know, it starts and then it keeps on going. It's self-sustaining. But when you're talking about nuclear fission, which is the splitting apart of a very large nucleus into smaller nuclei, the chain reaction can be of several different types. And so what we're going to do is demonstrate, first of all, what's called a critical process.
That's
and
a good
then
word.
A supercritical
So
one.
critical and
then we'll
supercritical.
talk about what the difference is. We'll look at the equation for it and so on. But as with a lot of things, it's best to start with the demonstration of it. So I think we're going to go ahead and do that. What we've got up here are two sets of dominoes. We're going to play a little bit today in chemistry class. We've got two sets of dominoes, and they're set up in two different patterns. The first pattern is a simple chain. It does have a couple of loop-de-loops in it, but otherwise, each domino is going to hit the next one in our chain. And that will be one type of chain reaction, because once it starts, we're not going to be able to stop it. So I've got somebody here who's going to start the timer as soon as I knock down the first domino. So on your mark, get set, go. Okay, stop. And that was 3 seconds. Is that right? 3 seconds. Okay. So that was a critical process. One domino hit the next, so one after the other. What I've got here is another setup of dominoes, but this time I've arranged them in a rather intricate pattern. I know, can we see that in the audience well? Can we focus on that a little bit? Is that good? Can we see that? Okay. And basically what you want to look at here is that, and this basically is, we have this set up on the board, on the bench top as well. What is going to happen here is that each domino hits two other dominoes.
So do you think this one's going to be faster or slower?
Super critical. So when I hit one domino right in the middle, it's going to hit two, those two are each going to hit two, and so on. And so that's going to multiply out. Did we catch that pretty well, do you think? Okay, so if we saw what that looked like, we're going to go ahead and try to time this one. Now here we got to be really good. You're back down to 0 time. Okay, and I'm going to hit this one right here in the middle, right? That'll be good? Okay, on the count of 3. 1, 2, 3. How long did that take? Not even a second, because I...
So that one was a lot faster.
We had a critical process here in 3 seconds and a supercritical process in 1 second. And then,
All right, so let's summarize and connect our notes to what we just watched in that video. Colton, hit one of the lights for me, please. All right, what is the main topic that we covered today? Fission. Has the bell ring?
Yeah, no.
Okay, so we talked about fission.
Are we on the back?
No, this is just a summary. What did we say that fizz means?
To expand.
Split.
To split, okay? So we know that fission is going to split something, okay? What particle starts it all?
Nuclear.
A different neutron, okay? So I have a neutron, and it's going to hit that big unstable uranium atom, okay? That uranium is what's going to get split, okay? So I have Ba and Kr, barium and krypton. What else comes out of this fission process?
3 more neutrons.
3 neutrons and lots of energy, okay? Lots of energy. Now, what are those 3 neutrons going to start? A blank reaction.
Nuclear reaction.
Happens over and over and over again. A chain reaction. Okay, and we just learned from that dominoes video that there's 2 types. Okay? So, she talked about a critical chain reaction. Was that the fast or slow one?
Slow.
Slow.
And then
What was the other one called? Supercritical. And that was the fast one. Okay, now going back to our note page that we filled out. Out of nuclear power plants and atomic bombs, which one do you think is supercritical? Atomic bombs, okay? If we're going to bomb somebody, you better believe that we are going to make it the biggest and most explosive ever, okay? So critical would be the power plants. Because that's more safe and we can control it a little bit better than supercritical. Okay, you're going to use your notes for this assignment today. On this assignment, make sure you listen so that you don't have to do more work than you need to. Okay, there's 3 columns, and there's some on the back as well, the same types of columns. Column 1 are easier questions, okay? They're only worth 2 points each. Column 2 are medium questions, they're multiple choice. They're worth 5 points. Column 3 are a little bit harder, but worth 10 points. You only have to do enough questions to get 50 points. So you don't have to answer every single question, okay? You can just do enough to get your 50 points. If you want to do more, go for it, okay? But the minimum is 50. Does that make sense to everybody? Yes? Okay. Whenever you finish, I need you to turn it into the tray. And that's all we're doing today. Use those notes to help you. You got to do 50 points worth. So you can't just do column 1 because that's only going to get you 20 points. Column 1 questions are worth 2. Tristan, well,